Hello, everyone.
Good morning. Can you hear me?
Yes, I can. Good morning, everyone.
All right. Thank you.
Mhm. Okay, good. So I think we should start. And for today, let's finish the chapter one. Okay, and I think for the next week, we have for Monday, right? We don't have any class. But I think I have already posted the assignment for several questions. Um, I don't think the question are difficult. If you are familiar with the concept, right, we have learned, you should be able to finish the assignments. But if you have any question, you can let me know or let TA know, okay? And you can submit your written paper or typed answer to Blackboard, okay? But make sure you should submit that before the deadline. Okay, for the for the first assignment, I don't think, just I mentioned, I don't think it's difficult. So when you have a time, you just finish assignments. Okay, so I think the deadline is September 14th, right? I set the deadline for almost 2 weeks. Okay. So let's start today's lecture. I think for last lecture, we ended at the networking layer or protocol layer, right? So we talk about why we need to have a layer, right? For a complicated system, what's the benefit of the layering, right? We can modularize each service with each layer, right? And we can easily maintain the different layer, update the different layer, but that's transparent to the other layers and service, right? So it's a good way to implement a complicated system, right? No matter a networking system or operating system or computer system, right? So this is a commonly used strategy in computer system research, okay? So here is uh, a figure to demonstrate what is a computer system from users to the hardware, right? Different layers. Okay, I think we also talk about the internet protocol stack, right? From the application level to the physical level, right? From application layer to physical layer. Let's go through that again. So for application layer, it's supporting the network application like email, HTTP, right, web, and then we go down to the next layer to transport layer. So it's the process to process data transfer. We have the TCP, we have UDP. Don't worry about what is TCP and UDP. We will give a very detailed explanation because this is the most important concept in networking. Okay, but you know that there is a transport layer here, and then down to the next layer, we have the network layer. It's a routing of the datagrams from the source to the destination, right? We have the IP, we have the routing protocols. Another next layer is a link layer. So the data transfer between the neighboring network elements. We have the Ethernet, we have the Wi-Fi, right? We have the different links. Though eventually we down to the physical layer, right? So the bits on the wire, right? The final layer of the internet protocol. So here are the five most important layers you should know for the internet protocol stack. I think after this class, um, when some people mention to you the layer structure for the internet protocol, that's a basic idea, right? From application, transport, network, link, and physical. This is something you should at least know or remember, okay? So let's see, maybe I should, okay. So let's see, this is um, uh, picture, or I mean the animation, right? So show how a message from the application layer sent to the next from the source to the destination, okay, and go through the different layer. And when you go from the first or the top layer to the down layer, you have to encapsulate each message, right? So how usually it will, happen, right? From the application layer, encapsulate one message and send it to the next layer and to the next link switch and to the destination. So here is a quick definition of the encapsulation. So it is a process by which lower layer protocols receive data from a higher layer protocol and then place the data into the data portion of its frame. So it's like you have the message, right? You have the data, you have a small portion of the data. You have to add something and encapsulate the your adding information and then send to another layer, right? Every time you need to add some information, right? Otherwise, the next layer doesn't know how you treat this data, right? So you have to add some small information to that packet or message or a segment or frames. So here is a definition of segment packet frame. But generally speaking, you don't need to worry too much about these things. We will talk about each layer when we go into the detail. But generally speaking, that's a unit, a protocol data unit, right? For different layer, you will have the different name for the data unit, right? For example, for the application layer, we usually call it a message, right? And then go to the transport layer, we will have another name for the data unit. It's a um, um, for the transport layer, it's a segment, right? And then it's packet, then it's frames. So let's first look at this animation. So if you have some message from the application layer, right, as noted as M, and then this message will go to the next layer, right, to the transport layer, and the transport layer will call this data unit as a segment and encapsulate this message, right, with some extra information HT here, and then go down to the next layer, right, to the network layer. Then this layer we call the data unit as a datagram, okay, and it will encapsulate another small information to the unit, right? And go down to the link layer. We add some more information, right, to the unit data unit. It calls a frame, right, in the data or link layer. Okay. Finally, go to the physical layer. Then go to the next switch to the router. Okay. And after that, we will need to decapsulate the data, right? Because it going to arrive on the destination. Okay. And then the data will go to the network layer, decapsulate, and go to the next layer one by one. And finally, it will arrive at the destination, right? And you can think about that as a decode, or usually we call it a decapsulate, right? To recover the original data, and the destination's application can use that data for anything you want to do, right? So I think this is just a quick demonstration of how a package or how a application data will send from source to the destination, goes through from the top to down, and then from down to top, right? So that's why this textbook or this class means from top to down, right? From top to bottom, right? And then from bottom to top, right? So you have similar to the previously example we use for the air travel, right? So from the ticket to the flight take off, then landing, and then you just take your baggage, and if you have any problem, you just claim or make a complaint to the ticket system from bottom to from top to bottom and bottom to top, okay? And each layer will encapsulate the message or the data and then decapsulate the message and data. So I want to say something more here. For example, I have a group of students doing the research for the compression stuff, so or encoding stuff. Similarly, we also have the encoding and decoding, right? So every time you have some message, right, if you want to reduce the data size, you have to do something to compress that data, but you have to put some extra information to encode that data, right? But once you receive the compressed format, you want to know what is the information in that compressed format. You have to decode, right? You have to extract the metadata from the compressed format and then recover the original data, right? Something similar happened in the network. And later we will talk about there is some compressed format transfer through the networking, right? Today we have a lot of information. We cannot just send all the original format of the data, right? Because, for example, if you have video, you don't want to send the original resolution of the video, right? In the network, you have some lower resolution, but it has a faster streaming speed, right? So similarly, right, some principle is similar here to the compression or decompression if you for familiar with encoding or decoding stuff here. Okay, so this is a animation for you, maybe help you can understand how the data transfer from the source to the destination through the different layer. Okay, so any question before going to the next slide? Okay, so if no question, let's go to the final part of this chapter. It's a history of the internet. Okay, so we have know a lot of basic concepts of the internet, of the network, right? And what's the history of the internet, how people develop the internet. So maybe some of you know that before the 2000, right, the internet is not very commonly used or commercialized, right? And the speed is quite slow. And sometimes it's only used for some specialized purpose, right? Or some military use case, right? Or some special use case. But nowadays, the internet is almost everywhere. So how people develop the internet and make it everywhere, right? What is the history? So I think before going to the slides, let's quickly look at a 4 or 3 minutes video. Okay, so the video will give you a quick overview of how the internet was developed. Okay, and then we can go to some detailed information. Let me try to play the video. Let me know if you cannot hear the sound, but I think last time it works, right? So I believe this time it should be working as well. Okay. So let me start the video, okay? I think I choose share the computer sound. Okay, good.
The internet actually got its start over 50 years ago, and computers back then filled up entire rooms. Scientists and researchers used it for years to communicate during the Cold War. It was useful because if one computer went down, the others wouldn't follow. In 1962, a scientist named J.C.R. Licklider proposed the idea of a network of computers that could talk to one another. In 1969, the first ever message was sent from one computer to another over the ARPANET, the government's computer network at the time. ARPANET stands for Advanced Research Projects Agency. One was located in a research lab in UCLA and the other at Stanford. All the message said was log in, and it didn't fail to crash the network. Stanford only received the first 2 letters of the message, but hey, you gotta start somewhere. By the end of the year, only 4 computers were connected to this network. In 1971, the University of Hawaii's Aloha Net was added, followed by various networks in London and Norway 2 years later. Also happening in 1971, Ray Tomlinson was developing the first system to send mail back and forth between the users of ARPANET. This would eventually be called electronic mail, or email for short. The @ symbol was used to tell a person's name and the host name apart. With all of the networks floating around, there needed to be a way for all of the computers on them to communicate with other networks. This is where computer scientist named Vinton Cerf comes in. He invented a way to introduce computers across the globe to each other in a virtual space. This invention was called Transmission Control Protocol, or TCP, which was followed by Internet Protocol, or IP. In the 80s, scientists used Cerf's protocol to send data back and forth, but the 90s is where it really all began. In 1991, a computer programmer named Tim Berners-Lee invented the World Wide Web. This wasn't just a data sharing space for scientists anymore, this was an entire network of information that was accessible to anyone with an internet connection. Now, you're using a browser right now to watch this video, and some of the popular ones are Firefox, Google Chrome, and Safari, but in 1992, Urwise was created. Urwise was an internet browser and the first to have a graphical interface. A few browsers came before and after, but in 1993, Mosaic was created, and it would popularize surfing the web. Mosaic influenced many of the browsers to follow, including Netscape Navigator in 1994. This became the most popular web browser at the time, accounting for 90% of the web usage in 1995. In the early 90s, companies like AOL and CompuServe were starting to provide dial-up internet access. Dial-up is a method of connecting to the internet via a telephone line. Your telephone line was plugged into a modem, and the other end was plugged into the phone jack. There was a period in history where you couldn't use your telephone and the internet at the same time. Without the internet, we obviously wouldn't have things like Facebook, Twitter, and YouTube, but way more importantly, we wouldn't be able to access information in seconds. We wouldn't be able to communicate with people from around the world, share ideas, and educate those who might not get a chance elsewhere. Also, without the internet, I'd actually have to talk to someone when I order a pizza, which, by the way, was the first thing ever purchased on the internet. How would your life be different without the internet? Let us know in the comment section below. This episode of Life Noggin is brought to you by Audible. Go to
So yeah, so this is a quick video. Let's go back to the slides. This is a quick video. Give us some idea. What about video? So it's I think it's a quick video, right? So give you some idea how internet was developed from 1960, right? And how it bloomed in 1990, and now everyone is using the internet, right? The pizza was also the first Bitcoin purchase. Yeah, so pizza is everywhere. Yeah. So yeah, this is a slide, first slide about the internet history, and I think in the video you notice that the ARPANET, right? So everywhere you when you talk about the internet history, ARPANET is the most important historical thing you have to mention, right? And I think before that, from 1961, right? So from theory level, people give the exam, give the theory part, theoretical part, right, to demonstrate that the queuing theory is effective, right, for the packet switching. So people, usually people will first propose the theoretical thing, right, before they can implement and design the thing can be used. So the theory has been developed in 1961, and then the packet switching has been developed as a military network. Okay, so in 1967, the DARPA, right? Some of you may know the DARPA, Defense Advanced Research Project Agency, right? In the history, I mean, so far, DARPA is still very important to fund many cool and important research for the national missions, right? So they found the ARPANET network. And as we know that the first ARPANET node operational is between the test between the UCLA and Stanford, right? And but at the beginning, the ARPANET only has 4 nodes at the beginning, right? But we can see that later, the ARPANET has developed for more than 30 or 300 nodes. So that's a story happened in 1970. Okay, so but for the between the 1960 to 1970, so the early packet switching principle has been developed, right? And some earlier experiment and operational things have been happening in that time period. Okay, and between the 1970 to 1980, so internet working and a new network has been developed, as I mentioned in the video, right? So the Aloha Net satellite network has been developed in Hawaii, right? So that network was using the satellite network, right? It's not limited based on the line, but you can use the satellite network in 1970, okay? And in 1974, I think this is a very important thing happening in the networking internet history, right? The Cerf and the Kind proposed as an architecture for interconnecting network. That's I think that's the original or the beginning of the TCP/IP concepts developed from the history. Okay, and their principle here is that Cerf and Ken's internet working principle is that they want to have the minimalized and ultimately that means they don't want to change a lot to the internal changes required if they to the interconnect networks. Okay, and they want to do the best effort service model, and they want to have a stateless routing right across states, and they want to have the decentralized control. Okay, so that defines the internet architecture. So I also want to share you one website. I think this website is very interesting. Let me share the website with you. Okay, so can you see? Oops. Can you see this website?
Yeah, we can.
Okay, so I think that's a very interesting website. Okay, it gives you some basic idea of, I mean, more details about the how internet begins and developed, and some interesting video here. Okay, let me try to play this video again. So it's quite an interesting video to me, at least. So you can hear about how Cerf talk about the first time he sent the first message through the internet from the UCLA to Stanford, right? So this is very interesting video.
In the mid-60s, the Department of Defense in the United States decided they needed a network, and they decided to implement the kind of technology I had been working on. And so it was decided that UCLA, my lab at UCLA, would become the first node, the first piece of the internet. And so in 1969, that did happen. And after the first node was installed at my laboratory, a second node was installed up at Stanford Research Institute, 400 miles to the north. And it was out of my laboratory that I supervised the transmission of the first internet message. So what was the first message of the internet? Do you know? You probably don't. So all we wanted to do was to log in, to connect from our computer to theirs. Now, in order to log in, we at our end have to type LOG, and the machine up at SRI will finish the message and type back the IN for us because it knows exactly what we're doing. So we're ready. We had a telephone connection as well as a data connection. We typed the L and we said, you get the L? Said, yep, got the L. Type the O, you got the O? Yep, got the O. Type the G, got the G? Crash. The network crashed. So what was the first message ever on the internet? Lo, as in lo and behold.
Yeah, I think that's a very interesting video to me, right? So you can see that for the first message in the word through the network is not complete, right? So the network crashed and they didn't even receive the complete words of the first message, right? So that's why the stable networking like TCP is really needed. So that's why the Cerf and Can invent the TCP protocols in 1970, right? So we can also see this video, right? How Vint Cerf and Bob can invent the TCP system. Okay, so here is a quick talk from the Cerf, I think.
Imagine that you have a book and you want to send it to your friend through a postal service that only delivers postcards. So what would you have to do? You'd have to tear the pages out of the book, probably have to cut them up, glue them on the postcard. And before you send the postcard, you notice that not every page has a page number because you cut them up, and you know they could get out of order. So you number every postcard. Everything you know about postcards applies to internet packets. When you put a postcard into the Postal Service, there's no guarantee it comes out the other end. It's a best effort system. If you put two postcards into the postal system, they don't necessarily come out in the same order that you put them in. So you have a system that doesn't guarantee order and doesn't necessarily even guarantee delivery. Then you remember that some of them may get lost, so you keep a copy just in case. And then you try to figure out, well, how do I know when I should stop sending postcards, or when do I know if I should retransmit them? So you get a great idea. You have the guy at the receiving end send you a postcard every once in a while saying, I got everything up to postcard number 420. And then you realize that his postcard might get lost. So if nothing else happens and you look at your watch and you haven't heard anything, you start retransmitting things that you'd already sent until you get a postcard saying, I got everything up to whatever it was. That's how TCP works.
Okay, so yeah, these are two videos from the people who invent the internet, right? One is the first message sent through the networking internet. At that time, maybe we don't want to call it the internet, right? But it's through the networking, right? Point to point, through UCLA to Stanford. And then how the Vincent Cerf and Bob can invent the TCP/IP system, right? So I think this is a very quick, short video to give you an idea how we will work with the packet sending system, but we can make sure that the sending and receive to be reliable, right? You can trunk the data into different packets, send the packets. It's not necessary to be in the order, right? And the receiver receive all the packets. They can recover the original information, right? But if they lost something, they just send the acknowledgement to the sender, right? And the sender will resend the lost information. So that's just a protocol, right? How protocol works. But for the TCP, UDP, that protocols, we will go very deeply in the next several chapters. But I think this is some basic idea, right? In the history, you have to know about that, right? The internet developers history. So let's go back to the slides again. Okay, so that's in 1974, right? Cerf and Ken invent the architecture for interconnecting networks, right? So the TCP/IP, TCP protocols. I think this is the reason why we call Cerf and Ken as a father of the internet, right? So TCP/IP is a very important beginning of the internet history. Okay, and sorry, yeah, I forgot to mention that in the 1980s, right, the new protocols have invented, for example, the SMTP for the email protocol, FTP protocol, DNS for name of the IP address. So for that website, I just showed that there's also a video about the DNS and the impact of the network. If you are interested, I put the link in this slide. Okay, you can go through that web page. I think that web page is a very quick introduction. You can learn about the internet history and some short interesting videos, I think, yeah. And from the 1990, right, the ARPANET network is decommissioned, right? So people are not using that. We're not using that anymore. But the new network has been appearing, right? So NSF lifts the restriction on the commercialized use of NSFNet, right? But it was decommissioned in 1995. Okay, but this is also important because that means the people from commercial company can start using the internet to do the business, right? Or to make the service to the our to us, right? So everyone can try to use the service through the commercialized company, okay? And in early 1990s, web, hypertext, HTTP just as mentioned in that introduction video, right? The www, right? So the web internet has been invented in early 1990s. Okay, so the late 1990s, the commercialize of the web has been, broader and broader. Okay, but nowadays after 2007, you can see billions from the 2007, right? The 18 billion devices attached to the internet. Nowadays, I think I believe it's maybe 100 times of the billions device attached to the internet, right? Because in 2007, iPhone just invented, right? But at that time, maybe not everyone has a smartphone, right? But nowadays, I believe almost everyone, or I mean, the person in the States, right, have the smartphone and access to the internet. Okay, and later increasing use of high-speed wireless access, 4G, 5G, Wi-Fi, and the emergence of the online social network, Facebook, right? We have the 2.5 billion of the users, and some large company like Google, Facebook, later they create their own networks because they hope their content information can be passed to the end user more quickly, right? And nowadays, I think many services are running on the cloud, in the cloud, AWS, Microsoft, right? Google Cloud, a lot of cloud service. So I think that's a general short introduction of the internet um, uh, history or development history, right? From the beginning, you only have a 2 machine, 4 nodes, right? To send and receive data. And you cannot receive the complete data, right, or message. Later, TCP/IP appears, and later different protocol appeared, FTP, right, email protocol, right, and later www appeared, and nowadays we have the cloud service and the high-speed Wi-Fi, social network, and the smartphones, right? So that's the general introduction of the internet. Okay, so. And question, I mean, if you are very interested in some more details, I encourage you to look at the this website, and also you can check the several videos. For this history, we didn't cover the development in the other country or region. For example, in Europe, actually, during almost the same time, Europe has also developed some internet protocol or a prototype, right? And they also contribute to the whole development of the worldwide networking or internet. But we just focus on some parts that happened in the States, okay? So I think that's main part to of the chapter 1. Okay, let's do a quick summary. So for the chapter 1, we have learned tons of the materials, right? We have know a lot of concepts, but these concepts we will refine it and go deeper in the next slides. For example, for the chapter 2, we will go to the application layer, right? To understand what is application layer, HTTP, some other stuff, okay? For the first chapter, we just do an overview of the internet, and then we give you an idea what is the protocol, right? And we know the network age, access network, the network core, right? Packet switching versus circuit switching, right? And the internet structure, which is a network of networks, right? And we know the performance of the network, loss, delay, throughput. And for these 3 concepts and performance concepts, you will do some assignments to calculate something here, okay? And later we know the layering service model, right, of the protocol stack, right, from the application to the network, transport, link, physical, right, different layers. And we know something about the security, right? Some bad guys try to leverage your networks, right, to get some bad things happen. And finally, we talk about the history of the network. Okay, so I think that's the first chapter. We will go deeper, as I mentioned, right, and with some more details. And if some detail I haven't mentioned in this part, we will go deeper later. Okay, but this is the first chapter. Any question here? I think that's it. That's almost the material for today. We don't have too many new contents today. Today we overview the history and we just review the network layer. Okay, so that's the content for today. Any question? And oh, okay. So for information, I have another thought about the exam question. I think take home exams. I agree that would be a easier way to implement. So if we want to do a protocol online exam that some student mentioned that's first is we need to pay some service fee, right, to implement that. And another thing that everyone is sitting in front of the computer. It may not be easy. So let's do the take home exam. But maybe some students are not here. I will send out I will send out the announcement later. Okay. Does that mean open book? Yes, I think so. If I ask you to take the exam back to home, I cannot control, right? So that means you can check the contents, right? So yeah, that's right. Okay, so any other clarification you need for the assignment? I don't think that's that's complicated, right? You just finish the question and submit to the Blackboard. Okay. So if no question, I think that's it for today. And hopefully you have a nice weekend, long weekend, and be safe, right? Because I received the email this morning. The university encourages students to stay at the Pullman, right? To be safe. Okay. I hope everyone to be safe and finish your homework and assignment. Okay. And look at some interesting videos posted here and learn some materials for the next chapter application layer. Okay. And see you on next Wednesday. Okay. Thank you, everyone.